Welcome to This Explainer. Today, we're tackling a very modern dilemma that I'm sure a lot of us are dealing with. How do we successfully collaborate with artificial intelligence to actually write better software? Look, we all know large language models are incredibly powerful tools for developers, but if you've ever actually tried to use one to review your code, you've probably noticed, well, it isn't exactly smooth sailing, right? Okay, let's dive into this. To really get the most out of AI, you kind of have to shift your entire perspective. Stop thinking of your AI as this infallible senior master developer. Instead, think of it as a highly enthusiastic, incredibly fast, but deeply naive intern who just pounded 3 cups of espresso. This intern is brilliant at reading code, sure, but without very strict rules and clear boundaries, this eager intern is just going to confidently make things up to try and please you. Our whole job here is to build a system that keeps this chaotic intern on track. So, here is our game plan. We're going to walk through a 5-step code review workflow. Along the way, we'll uncover 8 absolute essential rules for managing our AI assistant. We'll look at the core problem, how to prep the AI, keeping it focused, reviewing the right way, testing its output, and finally getting a clean, usable review. Now take a look at this. This is your master blueprint. Seriously, this single cheat sheet contains the whole secret to extracting accurate, relevant, and actionable reviews from an LLM. I know it looks like a lot to take in at first glance with its 8 different best practices and that step-by-step workflow, but don't worry. We're going to break this exact blueprint down, piece by piece, so you can actually put it into practice today. Let's kick things off with Section 1, the AI code review problem. Before we hand our AI intern its very first assignment, we have to understand its absolute biggest flaw. You can't fix what you don't understand, right? The core problem we're fighting here is something called hallucination. In simple terms, a hallucination is when the AI confidently invents completely fake code, or it assumes hidden logic that isn't actually there, or it just makes up project rules that simply do not exist. It wants to give you a helpful answer so badly that it will literally fabricate one if it feels it has to. So we must actively control this. And that brings us to a vital rule from our blueprint, Rule 4. Rule 4 commands us to control hallucination by forcing the AI to do one of 2 things. It must either cite specific file paths and line numbers for every single claim it makes, or it has to simply admit, I don't know. Let me tell you, giving your AI permission to just say, I don't know, is one of the most powerful things you can do. Moving right along to Section 2, prepping your AI assistant. This is step 1 of our workflow, providing input. Think about what you do on an intern's first day. You don't just shove a massive project at them and say, go figure it out. No, you give them the employee handbook. For our AI, this is Rule 3, provide a knowledge base. You've got to give the AI your specific project rules and standards before the review even begins. This means handing over your coding standards, your architecture overview, your specific naming rules, the whole 9 yards. Let the model read this and build its internal context so it judges your code based on your rules, not the entire internet's rules. But as we start feeding the AI all this information, we really have to be careful about tokens. If you aren't familiar with the term, just think of tokens as the AI's limited brain space, or its attention span. It's the absolute maximum amount of information the model can process and actually keep straight at any given time. Which perfectly tees up Rule 2, minimize tokens. Because the AI has this limited attention span, we absolutely must keep our input tight. Just look at the contrast here. On the left, an absolute disaster. Sending your entire massive project folder to the AI will just cause it to completely overwhelm and start hallucinating immediately. But on the right, that's the correct way. You're sharing only the minimal relevant functions, like a single simple add function. You want to proactively strip out comments, empty lines, and completely unused code before you ever hit send. You have to protect the AI's attention span. Now into Section 3, keeping the AI focused. Okay, so we've prepped our AI. Now we move into steps 2 and 3 of the workflow, where the model actually reads the code and begins its review. And here we have to keep it intensely focused. This brings us to Rule 1, stick to context only. The AI must use only the provided code. It is not allowed to assume or invent missing context. For example, the AI might try to guess, oh, this might fail if inputs are empty. But based on the specific rules of the language you're using, basic numbers literally cannot be empty, so the AI is just making a blind guess. The correct, context-aware review states actual facts. No empty checks are needed because basic numbers are required. We want facts, not guesses. To actually enforce this, you should physically copy and type this exact prompt tip into your AI tool. Only use given code, cite line numbers. If unsure, say, I don't know. Consider this the ultimate leash for your highly caffeinated AI intern. It explicitly forbids guessing and demands cold, hard evidence for every single observation it makes.
That brings us to Section 4, Reviewing the Right Way.
So now the AI is reading our code strictly within context. We need to establish exactly what it should, and honestly shouldn't, be looking for during this review phase. This leads to Rule 6, and this one might actually surprise you. Do not fix existing bugs. We want the AI acting as an advisor, right? Not some rogue developer making unapproved changes that might break your entire system. If there is a bug, like, say, using a single equal sign for an if statement, the AI should not rewrite your entire logic block to fix it. Why? Because it might totally misunderstand your ultimate goal and accidentally break something else entirely. Instead, the AI should just simply highlight the risk. Hey, possible issue with assignment instead of comparison here. Focus on improvements and identifying potential issues. Let the human actually write the fix. Now, while it's in there highlighting those issues, we want to make sure it's doing a genuinely comprehensive job. Rule 7 tells us to cover all key aspects. We want the model to evaluate the code from multiple, crucial angles. Don't just prompt it with, is this code good? That's way too vague. Ask the AI to specifically check for code quality and maintainability, performance and scalability, security risks, and edge cases. Force it to ask simple but critical questions like, is this secure from hackers? Or, what on earth happens if a user tries to upload a massive file size? Next up, Section 5, Testing and Validating Output. All right, once the AI has compiled its brilliant thoughts, we reach step 4 of the workflow, validation. We have to make sure the AI suggestions aren't going to just immediately crash our software. This is Rule 5, compile or test before output. If the AI is going to suggest a snippet of code or an improvement, it absolutely needs to ensure that code actually works. The workflow mandates 3 specific steps here. 1, run a linter. 2, compile the code. And 3, run tests if possible. The golden rule here is super simple. If the suggested code doesn't even compile, the AI shouldn't even present it to you, period. And hey, just to ensure we're all on the exact same page, if you aren't in the weeds writing code every single day, think of a linter and compiling as essentially your code's basic spell check and grammar check processes. They don't prove the code is a brilliant idea, but they do prove the code is technically valid and follows the rules of the programming language before it ever even tries to run. We are basically forcing the AI to spell check its own homework. And finally, Section 6, delivering the final review. At last, we arrive at step 5. The AI has read your rules, it checked the code, it validated its own thoughts, and now it's time to package all that hard work into something a human developer can actually use quickly. This brings us to our final rule, Rule 8, deliver actionable output. Because honestly, a massive wall of AI-generated text is completely useless to a busy developer. The output needs to be highly structured and prioritized. A great prompt forces the AI to output 4 very specific sections: a brief summary of the code, a strengths section noting what actually works well, an issues section that categorizes the real risks, and finally, actionable suggestions for improvement. Keep it clear, concise, and highly readable. So let's zoom out for a second and look at the complete review workflow now that we've successfully integrated all 8 of our management rules. It is a really clean, logical progression. 1, you provide scoped input in your project's specific knowledge base. 2, the model reads and actually internalizes those specific rules. 3, it reviews your code strictly in context, making 0 wild guesses. 4, it validates and compiles its own suggestions. And 5, it delivers a nicely structured, actionable review back to you. The source material summarizes this entire framework with one overarching golden rule for AI code reviews, and it's a great one to remember. Be context-aware. Be evidence-backed. Be constructive. Help make the codebase better. If you set up your prompts to ruthlessly enforce this one rule, your AI transforms from a chaotic liability into a genuinely incredible asset. I want to leave you with a thought to apply to your own workflows today. Take a good, hard look at the AI tools you are currently using. If an AI code review isn't truly context-aware, if it isn't strictly backed by evidence with specific line numbers, and if it isn't highly structured and constructive, is it actually helping your codebase at all? Or are you just creating more work for yourself trying to manage a chaotic intern? Thanks for joining me on this explainer, and happy coding!